Very good morning to all. In this lecture, we are going to discuss another topic from unit number 4, that is digital voltmeter, advantages, working principle, and what are the types of digital voltmeter. So what is voltmeter? As we know that voltmeter is nothing but an instrument which is used to determine the magnitude of potential difference between 2 points. And depending upon the nature of input electrical quantity, voltmeters are broadly classified into two main domains. First one is analog voltmeter and second one is digital voltmeter. Now, from the knowledge of our previous lecture, we know that analog voltmeter is capable to determine the value of voltage when the nature of input electrical quantity is analog in nature, or you can say it is continuous in nature. And for that, either we need to go for PMMC type instrument or you can say MI type instrument. Now let us focus on what is the concept of digital voltmeter. So digital voltmeter is nothing but a type of DMS. So I told you that DMS is nothing but digital measurement system, which consisting of various electronic devices as a subcomponent, with the help of which we are in a position to determine the value of voltage, or you can say potential difference between any 2 points. Now with the help of digital voltmeter, we are in a position to determine the value of both AC as well as DC voltage, and the instrument is designed in such a way that by using this device we are in a position to directly determine the value of unknown voltage and display as an output. So this indicates actual photography of a digital voltmeter. Again, the same thing is mentioned over here. So from this diagram, it is very clear that with the help of these digital voltmeter, we are in a position to directly determine the value of what? System voltage. It may be line voltage or it may be phase voltage. Now let us discuss the advantages of digital voltmeter. In the last lecture, we discussed the basic concept of digital measurement system, and in that we also have a detailed discussion on what are the advantages of digital measurement system or analog measurement system. The same advantages are applicable over here. So the first advantage is observational error in case of digital voltmeter is almost eliminated. The reason is very simple. With the help of this instrument, we are directly determine, or you can say see the value of unknown voltage as an output with the help of LED screen, or you can say LCD screen. In case of digital voltmeter, the parallax error is also eliminated. Reading can be taken very fast. The output of digital voltmeter can be stored in a memory device and it can be recollected at any point of interest depending upon our requirement for future computational work. They are versatile and accurate in nature. They are compact and cheap. If you see the photography of a digital voltmeter, it is very compact, or you can say small in size as compared to the corresponding same rating of analog voltmeter. The power consumption of such type of devices are very less during its working process. Actually, if you see a digital multimeter with the help of which we are in a position to determine the value of voltage, current, frequency. Sometimes they are also used to determine the value of unknown circuit parameter like resistor, inductor, capacitor. They required only 9 volt voltage source to measure the value of all such unknown quantities. Portability increases because of its small compact size. It is very easy to handle digital voltmeter as compared to analog voltmeter. Now let us discuss the working principle of digital voltmeter. In order to understand the working principle of digital voltmeter, let us consider a simple block diagram of voltmeter circuit. So actually, if you open a voltmeter, what is there inside a voltmeter circuit that we are going to study? So this indicates the basic composition of a voltmeter circuit. So from this diagram, it is very clear that it has mainly 4 components. First one is your pulse generator. Second one is AND logic gate. Third one is NOT logic gate, and fourth one is decimal display system. So let us discuss one by one what is the objective of all these subcomponents in a voltmeter circuit. So the first is input signal. So in this case, input signal is nothing but that input unknown voltage whose magnitude is to be determined with the help of voltmeter. Now what is pulse generator? Pulse generator is nothing but a voltage source which is capable to convert input analog or digital signal into output rectangular pulse. So I can say that it is nothing but a device which is going to convert the analog signal, or you can say digital signal, which is applied as an input to it, into a controlled rectangular pulse as an output. Now if you open a pulse generator unit, basically it has a combination of analog circuit as well as digital circuit. When I say that the output of pulse generator is nothing but a rectangular pulse, that means it has various parameter. For example, it has its width, it has frequency, it has amplitude, it has rise time, it has fall time. So definitely there are some subcomponents available in pulse generator which basically control various parameter of rectangular pulse. For example, in order to control the width and frequency of rectangular pulse which is generated as an output by pulse generator, it has a digital circuitry available in it. In the same way, it also consists of analog circuitry which is responsible to control the amplitude, rise time and fall time of that output signal. Next component is AND gate. We know that it is nothing but a basic logic gate whose output is high when both the input corresponding to it are high. That means the output is 1 when both the inputs are 1 1. Now from the basic circuit diagram of digital voltmeter, it is very clear that the input to AND gate are of two different types. One input is from train pulses and second input is provided as an output of pulse generator. And finally, if you see the overall operation of AND gate, the output of AND gate is nothing but a train pulse whose duration is exactly going to be equal to the duration of what? Rectangular pulse. So let us understand that particular concept via this diagram. Suppose here we are having AND gate and it has two input. So at one input we have applied this pulse of train or train pulses, and at another input we have applied this rectangular pulse which is nothing but the output of your pulse generator. And finally the output of this AND gate is possible when both the inputs are high. Now let us consider that this small t indicate the width of rectangular pulse which is generated by the pulse generator. Now within this particular span of time, whatever the pulse available at the input terminal of AND gate, it will provide straight away as an output. Now the next component which is implemented in the basic circuit of voltmeter is nothing but NOT gate. So NOT gate is basically perform the operation of inverting the nature of input quantity provided as an input to it. So in this case, if you see the diagram very carefully, the output of AND gate is provided as an input to NOT gate. So what it will going to do, it will invert the output of AND gate and it will provide output like this. It is basically going to act as an inverter. It will invert the input signal which is provided as an input to it. So in this case, as the output of AND gate is provided as an input to NOT gate, definitely it will invert the output of AND gate. Now the last component of voltmeter circuit is nothing but decimal display system. So it basically count the number of impulses which is provided as an output from NOT gate, and by using a suitable calibration method, it will indicate the magnitude of unknown voltage. So this is what the basic philosophy behind digital voltmeter. Now if you want to club the entire working process of digital voltmeter, we can club them step by step. So in first step, the unknown voltage signal is fed to the pulse generator which generate pulse whose width is proportional to the magnitude of input signal which we want to measure with the help of voltmeter. Second, the output of pulse generator is fed to one leg, or you can say one terminal of AND gate. The input signal to another terminal of AND gate is nothing but a train of pulses. The output of AND gate is a positive triggered train of duration exactly equal to the width of rectangular pulse which is generated by a pulse generator. This positive triggered train is then provided as an input to inverter which is nothing but a NOT gate which convert it into a negative triggered train. The output of inverter is then fed to a counter, then depending upon a suitable calibration scale provided inside it, it will count the number of trigger which is proportional to the magnitude of input voltage which we need to measure with the help of this arrangement. So this is what the basic working philosophy behind digital voltmeter. कहने का मतलब ये है कि अगर आपको डिजिटल वोल्टमीटर का एग्जाम में अगर पूछा गया कि व्हाट इज द वर्किंग प्रिंसिपल of a simple digital voltmeter, the thing is that you need to explain all these steps one by one. तो सबसे पहले हमारे पास में जो इनपुट क्वांटिटी है या फिर जो इनपुट वोल्टेज सिग्नल है जिसका मैग्नीट्यूड हमें मेजर करना है, वो हम लोग प्रोवाइड करेंगे एज एन इनपुट टू योर पल्स जनरेटर, जो आपको आउटपुट में देगा एक कंट्रोल्ड रेक्टेंगुलर पल्स. वो कंट्रोल्ड रेक्टेंगुलर पल्स आप इनपुट में दोगे आपके एंड गेट के एक टर्मिनल को, और दूसरे टर्मिनल पे आप प्रोवाइड करोगे आपके ट्रेन पल्सेस को. फिर उसका जो आउटपुट आएगा विच इज नथिंग बट ए पॉजिटिव ट्रिगर्ड ट्रेन पल्स इज प्रोवाइडेड एज एन इनपुट टू योर नॉट गेट, विच बेसिकली इन्वर्ट the output of AND gate and convert them into a negative triggered train, and then the output of that NOT gate is provided as an input to your counter, followed by decimal display system, with the help of which we are in a position to determine the value of that unknown voltage directly. So from the above discussion, it is very clear that a digital voltmeter is nothing but a type of analog to digital converter which convert the input unknown analog signal into a train of pulses, and on the latter stages they are counted with the help of counter by providing a suitable calibrated scale in order to determine the value of unknown voltage. So the functional block diagram of digital voltmeter can be given as like this. So from this diagram it is very clear that a digital voltmeter has mainly 4 components in it. First one is attenuator, second one is analog to digital converter, third one is counter, and fourth one is your readout system. Now from the diagram it is very clear that the main working component of digital voltmeter is nothing but analog to digital converter. So depending upon the type of analog to digital converter, the voltmeters are also classified as RAM type digital voltmeter, integrated type digital voltmeter, potentiometric type digital voltmeter, successive approximation type digital voltmeter, and last one is continuous balance type digital voltmeter. Thank you.